This is a stick.
What?
A stick.
Okay.
Finding the volume of a solid with known cross sections. Today, we'll be teaching you how to find the volume of solids created by cross sections. Step 1. Draw pictures of the base and the cross section. So, here we have an example base, which is two curves, actually a line and a curve, bounded by A and B to form our region. And then we have four example cross sections: a square, semicircle, equilateral triangle, and isosceles right triangle. Please note that for cross sections perpendicular to the x-axis, you'll be using dx integration, and for cross sections parallel to the x-axis, you'll be using dy integration. Step 2. Determine the general formula for the area of your cross-section. So, depending on your cross-section, you're going to plug in the side for that formula. For example, the area for a square is the side squared. Area of a semicircle is the radius squared times 1/2 pi. And also use formulas for equilateral triangle and isosceles right triangle. Step 3. This is when you determine the length of the base, which is in the same direction as the cross-section. So, as we move from -3 to 3, you're finding the side that's changing on your cross-section. So, in our case, from this yellow line from the top to bottom is our cross-section side that is changing. So in this case, because this is a circle, we use two equations for a semicircle in the first and second quadrant and the third and fourth quadrant. So this side length will always be 2 times the square root of 9 minus x squared from -3 to 3. Next, take your side value that you found. So in this case it was 2 times the square root of x squared minus 9, or rather 9 minus x squared, and plug that in as f of x and integrate from your bounds. So to find your bounds, you find for dx integration the leftmost and the rightmost, or for dy the bottom to top. So here's a quick example which we have alluded to in previous slides. So in this case, we're trying to find the volume of a solid generated by cross-sections perpendicular to the x-axis of this circle, x squared plus y squared equals 9. So let's start with writing our region and our cross-section. And then after that, we have the side formula for a square, so the area is equal to the side squared. So then we have to find the actual side, and so the side is equal to 2 times the square root of 9 minus x squared, which we explained earlier with the semicircles, and then you just plug that side into this general formula and put it in your integration. And also note that this goes from -3 to 3. And then once you have your integral, plug it in your calculator, and wow, gee whiz, we get 144. What a great number. Thanks for learning with us today.